geometry to our current section, RTT6. This is part 2, looking at the inverse of trig ratios. Every operation has something that undoes it that we've encountered so far. Multiplication has its inverse division, square roots have their inverse squares, subtraction has its inverse addition. So these trig ratios are actually operations that we can use to find the ratios of the sides that they correspond to. So we can use the inverses to find the angle measures. So remember that the sine of angle A, and we write the letters in our reference triangles. The capital letters go on the vertices, and we're going to write the lowercase letters across from them because remember the side opposite corresponds in size. So our C is our longest side because it is across from our right angle. B is across from B, A is across from A. So since sine, the sine ratio was the opposite over the hypotenuse, the side opposite A is A, and the hypotenuse is C. So the sine of B, still opposite over hypotenuse, but the side opposite B is lowercase b, so it's going to be b over still the hypotenuse, C. So when I want to find a missing angle, I'm still going to write the trig ratio the same way. The sine of x is, I'm going to refer to this 12 as the opposite. This is the opposite side, and this is the hypotenuse. So sine of x equals 12 over 17. But instead of solving for a missing side length, this time I know both side lengths. So the sine of x is equal to 12 over 17. And there's only one angle that has that specific sine ratio. There's only one angle in a right triangle that has that specific sine ratio. And so we are going to take just like we do with any other inverse, we do it to both sides. The sine inverse of sine x, and the notation for sine inverse, it looks like we're taking it to the -1 power, but it's just part of the notation. Sine inverse of sine x equals the sine inverse of 12 over 17. And just like all other inverses, it cancels its operation, or it cancels its inverses operation. So the sine inverse of sine of x is just x. And then the sine inverse of 12 over 17 we can evaluate in our calculator. So when I open up my calculator, on this one, I don't see the sine inverse, I just see sine, cosine, and tangent. So we're going to hit these two arrows here for my calculator anyway. On the calculators we have in class, you hit the second button, and then the sine, cosine, and tangent buttons are the secondary operation on those same buttons, sine, cosine, and tangent. So sine inverse, and notice it says a sine. That's because there's another notation for sine inverse called the arc sine. So sine inverse or arc sine. Okay, arc sine. Same thing with cosine. There's the arc cosine. Cosine. Goodness sake. Arc cosine, and for tangent, it's the arc tangent. Arc tangent. Okay. So if you see that a sine notation or arc sine notation, that's what that means. It's just the sine inverse. That's it. So this is sine inverse. So we're evaluating the sine inverse of 12 over 17. So we'll just type it in just like that. Arc sine, sine inverse of 12 over 17. And then we'll close the parentheses. Okay, so that quotient is in the parentheses, 12 over 17. And it gives me 44.9. Got some zeros following that, but 44.9 is my angle measure, 44.9 degrees. Okay, so now we have another really powerful tool for finding missing measures on right triangles. For arc cosine, or cosine inverse, the cosine ratio is adjacent over hypotenuse. So the side that's adjacent to angle A is B, and the tangent is C. Cosine of B, the adjacent leg to B, is A, but it's still adjacent over hypotenuse. Adjacent is A in this case, and then C. And remember what I said in the last section. I said that the cosine is the sine of the other angle. So notice that the sine of A over C, is the cosine of B, A over C. Okay, so the sine of A is the cosine of B. The sine of B is the cosine of A. So when I want to solve for x, I want to solve for this angle, and what I have is the adjacent leg and the hypotenuse, adjacent, and hypotenuse, I can write this equation. The cosine of x is equal to, notice cosine of angle is equal to adjacent over hypotenuse. Cosine of x is equal to 5 over 9. So then when I solve, I can take the inverse of both sides. Cosine inverse of x, or cosine inverse of the cosine of x is just x, is equal to the cosine inverse of 5 over 9. Okay? So we don't have to actually write out the sine inverse of sine of x. I just did that to demonstrate what it is that we're doing. You can go straight from cosine of x is 5/9 to x equals the cosine inverse of 5/9. Okay? But what we're doing is we're taking the cosine inverse of both sides. Is equal to, and we can type that in our calculator. Okay, so we have the, let's clear that out, cosine inverse, arc cosine, of, and this was 5/9, 5 divided by 9, close the parentheses, we get 56.25. So 56.25 degrees. We found our angle measure that has that cosine, that has that ratio of those sides. Okay, and these other two over here, we'll do those in class together, just to make sure that we're on track and we can discuss it further. This one, the circle's covering it up, but remember this was the capital A, just like in the other ones. So tangent of capital A is equal to the opposite over adjacent legs, just like in the previous section. Opposite over adjacent. So the opposite leg is A, the adjacent leg to A is B, and tangent of B, opposite over adjacent still. And in this case, the B is the angle we're referencing. The opposite to B is B. The adjacent is A. So the tangent of A and tangent of B are reciprocals. When I want to find x, and the information that I know are the two legs, this is the opposite leg and this is the adjacent leg, I'm going to use tangent. Tangent of x equals opposite over adjacent. Tangent of x equals 5 over 12. So then x, we can solve for x by taking the inverse tangent. Inverse tangent of both sides gets us tangent inverse, or arctangent, of 5 over 12. So we can, in our calculator, go with the tangent inverse, or arctangent, of 5 over 12. 5 over 12, close the parentheses, arctangent of 5 over 12. 22.62. 22.62 degrees. So the angle that has that tangent ratio is going to be 22.62. In fact, I know we hadn't been checking our answers earlier, but if I take the tangent, let's go back to the primary tangent, not inverse tangent, tangent of 22.62, oops, tangent of 22.62, I get this 0.416 repeating, so, or 0.41, I'll say 0.42. 0.42 is probably close enough, 0.42. And then if I divide 5 by 12, if I divide 5 by 12, I get 0.42. Okay, so the the tangent ratio gets me that ratio of those two sides, tangent ratio of that angle. Okay, and once again, we'll do that last one in class. We are splitting this up into 3 days, so this was day 2. We're going to look tomorrow at some applications of trig functions. What are these good for? How can we use them practically? So look forward to that, and I'll see you in the next one. Bye for now.